And in this session, we are going to understand the fundamentals of mathematics and why we need these fundamentals is these things will help us in understanding the algorithms and cryptography in the later on sections. We'll see what these fundamentals are. So we have learned all these things in our school days, maybe in our primary classes, and we are just going to refresh all these concepts. We're going to look at what is a whole number, what is a natural number, what is a factor, what are prime numbers, what are composite numbers, how do you find a greatest common divisor for a given set of numbers, what are coprime numbers, and we'll also look at the mod operator. So we'll start looking at the definitions one by one. What is a whole number? Any non-negative integer is called as a whole number. So it's starting from 0, 1, 2, 3, and then the set goes on. So all the set of numbers starting from 0 and so on are called as whole numbers, and we have to keep in mind whole numbers are integers and they do not have a decimal part. The next question is, what are natural numbers? All the set of numbers starting from 1, 2, 3, 4, and so on are called natural numbers. Natural numbers are numbers that are greater than 0, and natural numbers are also known as counting numbers. What is a factor? A factor is a number that divides another number evenly without any remainder. So let me give an example. For instance, we say 4 is a factor for 8. Why we say 4 is a factor for 8? So when you divide 8 by 4, you're going to get a remainder of 0. So what is the remainder? Remainder will be 0. So if a number evenly divides another number and leaves no remainder, we call that number to be a factor. And there's another definition for factors too. Factors are numbers you multiply to get other numbers. For instance, 8 can be written as 4 into 2. So 4 and 2 are factors for 8. Likewise, 8 can be written as 1 into 8. 1 and 8 are factors for 8. So what are the factors for 8 we have identified? It is nothing but 1, comma 2, comma 4, comma 8. So these are the factors for 8. So that's what this definition says. Factors are numbers you multiply to get other numbers. Now let us go and take a look at prime numbers. Prime numbers play a very important role in cryptography. So we have to understand the basic definition of prime numbers. We all know that. What is a prime number? A prime number is a number greater than 1 and it has only two factors. These two factors are nothing but 1 and the number itself. For instance, if you take 3, we say 3 is a prime number because it has got at most two distinct factors. I can represent 3 as 1 into 3 and it has only two factors, and these factors are 1 and the number itself. Likewise, when you take 5, 5 can be represented as 1 into 5 and it has only two factors, and the factors are 1 and the number itself. So that is a prime number, and we say 1 is not a prime number because it is not having two distinct factors. You can represent 1 as 1 into 1, but these are not two distinct factors. So we say 1 is not a prime number. And I have given you some sample prime numbers here. What is a composite number? Any integer that is greater than 1 and it has more than two factors. These are called composite numbers. For instance, when you take a look at 8, we say 8 is a composite number. Why? Because 8 can be represented as 1 into 8. 8 can also be represented as 2 into 4. So the factors for 8 are 1, comma 2, comma 4, comma 8. So the number of factors we have here is greater than 2. So once when you have a number that is greater than 1 and the number of factors is greater than 2, we call such numbers to be composite numbers. So positive integers that have more than two factors are called composite numbers. Now let us take a look at greatest common divisor. What do you mean by a greatest common divisor for a given set of numbers? Let us consider two numbers a and b. So the greatest common divisor for these two numbers can be C if this is the greatest positive integer that divides both these numbers. So that is a greatest common divisor concept. For instance, let's consider this example here. For 12 and 8, what are the divisors? For instance, when you take 12 and 8, you can see 2 evenly divides 12 and 8. So 2 into 6, 2 into 4. So 2 divides both 12 and 8, whereas we have 4, 2. 4 also divides 12 and 8. So 4 into 3 and 4 into 2. But you see, the greatest common divisor for 12 and 8 is 4 because this is the greatest positive integer that divides 12 and 8. So we call 4 to be the GCD for the given numbers. And this again is a fundamental concept that we have learned earlier. So what is the greatest common divisor? It is the greatest positive integer that divides a given set of numbers. How to find GCD? You can recollect, you would have used some strategies to find GCD in your school days. We look at one of the popular strategies, that is GCD by division method. For instance, if we have to find the GCD of A and B, what we do is we find the greatest of these two numbers. Let's assume that B is the greatest. So what we do is we take B and then we divide it by A. Say we get some quotient and we'll get some remainder. So once when you get a reminder, you take this divisor and then you again divide it by the remainder. So once when I divide it, say Q dash, and then I get A, the remainder goes to 0. So this divisor, which has led to a 0 remainder, will be considered as the GCD for both these numbers. So R is the GCD for A comma B. So that is the division method. We'll understand the division method taking a very simple example here. Let me go and erase all ink on the slide. So let us find the GCD of these two numbers, 30 and 45. So how will you find the GCD of these two numbers using the division method? So you take 45, the greatest number, and then you divide it by 30. So 30 into 1 is 30. And what is the remainder here? 15. So once when you get a remainder, you take this divisor and you divide it by the remainder. So 15 into 2 is 30. So now you get a 0 remainder. So this divisor which led to a 0 remainder will be called as the GCD. So GCD for 30 and 45 is 15. So you call this to be the greatest common divisor. Now I want you to take some exercises. You must give me the GCD of 442 and 546. Tell me what is the GCD for this. Likewise, you can also take up this exercise. You take three numbers and you find what is the GCD for these three numbers. See, GCD and prime numbers, all these things are very important. We'll be using this frequently in our coming sections in our algorithms and cryptography. So that's why I'm taking some time so that you can refresh and understand what is GCD and what is how do you find GCD. So did you find the GCD of 442 and 546? So when we take 442 and 546, which is the greatest number here? 546 is the greatest number. So we take 546, we divide it by 442. So 442 into 1 is 442. And what is the remainder here? 104. So once when you get a remainder, you divide it with the divisor, that is 442. So 104 into 4, that will be nothing but 416. So what is the remainder here? This is 26. So once when you get a reminder, you divide it with the divisor. So 26 into 4 leads to 104. So you get a reminder as 0. So the divisor which led to a 0 reminder is called the GCD. So GCD for 442 and 546 is nothing but 26. Now can you try and tell me the GCD of these three numbers? Okay, let us find the GCD of these three numbers that we have taken. That is 442 and then the next number is 546, and then the next number is 424. So what is the greatest number here? 546. So we'll take 546 and then we'll divide it by 424. So 424 into 1 is 424. So what is the remainder here? It is 1, 2, 2. So once when you get a reminder, you take this divisor 424 and divide it by 122. So 122 into 3, that actually gives us 366. So what is the reminder here? We'll get 58 to be the reminder. And once when you get a reminder, you take this divisor and divide it. So it is 122. And now 58 into 2 is actually 116. And now what is the reminder? It is 6. So you have a reminder, you take this divisor 58 and then try and divide it. So 6 into 9 is 54. So what is the reminder? 4. You take this divisor 6 and then you divide. 4 into 1 is 4. You get 2. You take this divisor 4 and you divide. 2 into 2 is 4, 0. Yeah, lengthy division, and this is the divisor that led to a 0 reminder. So for 424 and 546 we have 2 to be the GCD, but we have 3 numbers here. So what we'll do is we'll take this 2 and then we'll try and use the third number 442. So we'll divide 442 by 2. What is that we are going to get? 2 into 221 is 442. So the remainder is 0. So for the three numbers that we have taken, the GCD is nothing but 2. So what is the GCD for all these three numbers? GCD for all these three numbers is nothing but 2. So that's how you find the GCD using the division method. So now let us take a look at what are co-prime numbers. Co-prime numbers are any two numbers that has the GCD to be 1. So set of numbers that have GCD as 1 are called co-prime numbers. For instance, when you take numbers 7 and 8, 7 and 8, the greatest common divisor for 7 and 8 is 1. So we say 7 and 8 are co-prime numbers. Let's take a look at some of the properties of co-prime numbers. One is a co-prime number with every other number. So when you take 1 and 8, the greatest common divisor is 1. When you take 1 and 10, the greatest common divisor is 1. So 1 is considered to be co-prime with any other number. Very simple. Prime numbers are co-prime to each other. So you take an example 3 and 5. What is the greatest common divisor for 3 and 5? It is 1. So once when you have the greatest common divisor for a set of numbers to be 1, we say these numbers are co-prime numbers. And there's one more property. Any two successive number is always a co-prime number. For instance, you take any two successive number 18 and 19. The GCD for this is 1. You can go and very well check that for 18 and 19, the greatest common divisor is 1. What about 19 and 20? Any two consecutive numbers, the GCD will always be 1. So we say these kinds of numbers are co-prime numbers. There's another interesting property. Sum of any two co-prime number is always co-prime with their product. For instance, let me take two co-prime numbers, 2 and 3. What is the sum of 2 and 3? That is 5. What is the product of 2 and 3? That is 6. Again, when you take 5 and 6, these two numbers are again co-prime. So what this property says is you sum two co-prime numbers and you find the product of that two co-prime numbers, and that result will also be co-prime. So that's what we have seen here. The sum of any two co-prime numbers is always co-prime with their product. I hope you're all clear with what a co-prime number is. So can you identify the set of co-prime numbers here? Are 24 and 36 co-prime? Can we find the GCD? So we have 36 and then we have 24. Into 1 is 24. So we have 12 here. and we have 24. So 12 into 2 is 24. So it is 0. So 12 is the greatest common divisor here. So since the GCD is not 1, this is not, these two numbers are not co-prime. What about 20 and 21? Using the property, we can very well say these are co-prime because they are consecutive numbers. What about 542 and 446? We know that the GCD for 542 and 446 is 2. Since the GCD is not 1, these two numbers are not co-prime numbers. We are now venturing into another very important concept in number theory, modular arithmetic. And it is very important you understand the fundamentals of modular arithmetic to understand much of the algorithms in the later sections. Before even going in depth into modular arithmetic, let us understand this algorithm on division. A division algorithm is a pretty simple basic algorithm. For instance, let's say we have two integers n and a, and if you're going to divide a by n, obviously you'll get a quotient and then you're going to get a remainder. So when you divide a by n, you can always represent a. This a can be represented as, it is nothing but n times q, n into q plus r. So this is the property. When you divide a number a by n, a can be represented as n into q plus r. Let's take an example here. Say for instance you have 5, you divide it by 3. So 3 into 1 is 3. You get a remainder 2. So you can take this 5 and you can represent that as nothing but 3 into 1 plus the remainder is 2. So 5 can always be represented like this. This is the exact meaning of this. And what is R? R is the remainder. And there is a rule that R should always be between 0 and less than n. So this remainder can always be anything from 0 to less than n. So this is n. 3 is n. And what is q? The quotient. Q is nothing but you are dividing a by n, so you're getting the quotient. So that is the meaning of this. So this is the division algorithm, and what we understand here is when you are dividing a number by another number, we can always represent a is equal to nq plus r. Remember this algorithm. We'll also be using this later on. We have to understand the concept of what is a divisor. So let me tell you what is a divisor here. A divisor is a number that exactly divides another number and it leaves no remainder. For instance, if there is a number a and there is a number b, if b divides a, so what will be the remainder? Remainder will be 0. So this is a, this is b, and b divides a. So we can always represent a is equal to bm. We say b is a divisor of a. So let's take an example here to understand this. It's very simple. Say we have 6 and we divide that by 3. So 3 into 2 is 6. We get a remainder 0. And we say 3 is a divisor for 6. And we can always represent 6 like this. 6 is equal to 3 into 2. Here 6 is A, 3 is the divisor B, and M is 2. Is that clear? So what is a divisor? We say that a non-zero b divides a if a is equal to mb for some m where a, b and m are integers. We say b divides a if there is no remainder on the division. So when you have something like this, we can say 3 divides 6. So this is the notation. It's not 3 by 6, it's 3 divides 6. Why we say 3 divides 6? Because there is no remainder upon this division. And we can also represent 6 is equal to 3 into 2, where 3 is b and 2 is m. So this is like a is equal to bm. That's what is the expression given here. So whenever you have this concept called divides, when I say 3 divides 6, you know what does that mean? So when I say B divides A, it means B evenly divides A and gives no remainder, and B is called a divisor of A. Is that clear? Okay, now let us take a look at the properties of a divisor. The very first property says if A divides 1, then A should be plus or minus 1. So it's very simple. If any number, say if it divides 1, then it should definitely be plus or minus 1. So that is the first property. And the next property is if A divides B and B divides A, then A is equal to plus or minus B. Even this is straightforward. Say when 5 divides minus 5, we can also have minus 5 dividing 5. So finally what we conclude, when A divides B and B divides A is equal to plus or minus B. So this is also done. And the next property is if B is a non-zero integer, then B divides 0. So it's simple. You have 0 by B is always equal to 0. For this, the important condition is B should not be equal to 0. That is because if you divide any number by 0, that is actually undefined. So that's why we come with this condition. B should be non-zero to divide 0. Now let us take the next property. If B divides G and B divides H, then B divides the linear combination of Mg plus Nh, where M and N are arbitrary integers. So this is the next property. We can go and see the proof for this property. For that, let me go to a white screen and explain you how that one works. So what we need to prove is if B divides G and B divides H, this implies B divides Mg plus Nh, where M and N are integers. So we'll go and have this proof. So when we say B divides G, it just means G is equal to B into K. So this is the property of a divisor, right? We have seen A is equal to Bm. So that is the format I have written here. So when B divides G, G is equal to Bk. Likewise, when B divides H, what we can say about H? H is equal to B into K dash. So some value. So these two things take this format. We have seen this in the definition of a divisor. So now we have the value for G and we have the value for H. What we are going to do is we are going to take this Mg plus Nh. So it is Mg plus Nh. We'll substitute the value for G and H here. So it is nothing but M into Bk plus what is N? H? It is N into Bk dash. So since B is common here, we can take B out. So what is remaining is Mk plus Nk dash. And this is equal to Mg plus Nh. So this equation given here actually is of this form. Say here M, K, N, K dash are integers. So we can just consider that to be some integer, say B into M. And so it is Mg plus Nh is equal to B into some integer. And this is like A is equal to Bm. So in that case, what we can say, B divides Mg plus Nh. So we have proved this. So what we understand from this, when B divides G and B divides H, B divides the linear combination of Mg plus Nh, where M and N are considered to be integers. So we have arrived at the proof. So that's all about the properties of divisors.